everyone, let's talk about the real-world applications for solving quadratics by factoring, aka word problems. So what we're going to do, just like we've done in the past, is read through the problem carefully, highlighting key information that will help us solve the problem. So number 1, programming. Ray is a computer programmer. He needs to find the quadratic function for this graph for an algorithm related to a game involving dice. Provide such a function. Alright, so what we want to do here is our goal, alright, for highlighting key information is to find the quadratic function for this graph. So the first thing we want to do is analyze this graph. Now, we've been talking about factoring and roots and solutions, and what exactly is a factor? Alright, so a factor is how we can write a quadratic function based on the solutions, right? Essentially, we're working backwards. So the solutions are where the graph crosses the x-axis. So we know we have one solution at x equals 7 and one solution or root or 0 at x equals 11. So these are our two roots / solutions. Oops. All right, because these are all names. X-intercepts, root, solution, all the same name for the same thing. So x equals 7 is one and x equals 11 is another. Now, if we want to find the factors for these solutions, all we do is make it set equal to 0. So if we want this x equals 7 to be set equal to 0, subtract 7 from both sides. And then we end up with x minus 7 equals 0. And do the same thing for the other equation. So we end up with x minus 11 equals 0, right? Because these both cancel out. Now, here's our two factors, x minus 7 and x minus 11. Right? Those are our two factors because our solutions are set equal to 0. So what we would do is we would go over here and we would write f of x equals x minus 7 times x minus 11. And that is our function in factored form. Now we want to write it in standard form, so what we want to do is FOIL this out. Alright, so we're going to do multiply the first, outer, inner, last. So we end up with f of x equals x squared minus 11x minus 7x plus 77. We combine like terms, so we end up with f of x equals x squared minus 18x plus 77. And there's our quadratic function in standard form, and we just found the quadratic function for this graph. Alright, number 2, art. The area in square inches of the drawing, I'm not going to even try to pronounce that, alright, because I can't speak French. You guys can read it. Hopefully, if any of you can speak French, let me know how to pronounce that. By Claude Monet is approximated by the equation y equals x squared minus 23x plus 130. Factor the equation to find the two roots, which are equal to the approximate length and width of the drawing. Alright, so if we find our two roots by factoring, then we're going to find the approximate length and width of the drawing. Alright, so that's our goal, is to factor the equation to find the two roots. And that'll give us length and width. So what we want to do is we want to start with this quadratic function, and we want to factor it. Alright, so this is our function, f of x equals x squared minus 23x plus 130. So because a equals 1, we're going to factor this using the diamond method. Alright, so 130 goes on top, negative 23 on the bottom, and we want to find two numbers that multiply to 130 and add up to 23. Add up to negative 23. If we can't think of them off the top of our head, we start by listing out the factors of 130. So 130 times 1, 2 times 65, that's not going to give us negative 23. 5 times 26, still not going to give us negative 23. Next one would be 10 times 13. And then that's our winner, because we can make a negative 10 and negative 13. And that's going to give us positive 130 and negative 23. So negative 10, negative 13, there's our two factors. So then we're going to write this function in factored form. So f of x equals x minus 10 and x minus 13. There's our function in factored form. Now, if we want to solve for the two roots, what we're going to do is set each of these factors equal to 0. So x minus 10 equals 0, x minus 13 equals 0. Add 10 to both sides. So x equals 10. And x equals 13. So there's our two solutions, or our two roots. Now we're talking about the length and width of the drawing, so we would say the length and the width of our drawing is 10 inches by 13 inches. And that's our final answer, put back into the context of the problem. All right, number 3. A computer graphics animator would like to make a realistic simulation of a tossed ball. The animator wants the ball to follow the parabolic trajectory represented by the quadratic equation, this one right here, negative 0.2 times x plus 5 times x minus 5. Now, part A is asking us what are the solutions of f of x equals 0. So in order to solve for that, what we want to do is we want to set each factor, so each factor would be negative 0.2, x plus 5, x minus 5. Set each factor equal to 0. So negative 0.2 equal to 0. Now that doesn't equal 0, so we don't have a root or solution for that. False mathematical statement. Then x plus 5 equals 0, and x minus 5 equals 0. So subtract 5 from both sides. There's one solution. Add 5 to both sides. And there's another solution. Now, if we want to write f of x in standard form, what we got to do is multiply it out. So I might run out of space here. Let's see if I can do this in this tiny little space. So f of x equals negative 0.2 times x plus 5 times x minus 5. Let's start by foiling out x plus 5 and x minus 5. So we end up with negative 0.2, and we end up with x squared plus 5x minus 5x minus 25. So those are going to cancel out, and we're left with negative 0.2. I'm running out of space here. Where else can I write this? Let's go over to the side here. So we end up with negative 0.2 times x squared minus 25. Then we just want to distribute. So we distribute negative 0.2 to the x squared and to the negative 25. So we end up with f of x equals negative 0.2 x squared. And then if we multiply negative 25 by negative 0.2, we end up with positive 5. And there's our function in standard form. Now part C is asking, if the animator changes the equation to negative 0.2x plus 20, what are the solutions? So what we want to do is we want to take this equation right here and we want to factor it. So start by working backwards, right? If we have f of x equals negative 0.2x squared plus 20, first thing we want to do to factor this is take out a GCF. So here our GCF would be negative 0.2. And if we take that out, we end up with x squared, and then 20 divided by 0.2, by negative 0.2, is going to give us negative 100. Then we want to factor x squared minus 100, and this is difference of squares. So we end up with negative 0.2, x plus 10, and x minus 10. All right, because we've got x squared minus 10 squared, right? So our a is x, b is 10. Now, we've got it in factored form, so now set all of our factors equal to 0. So negative 0.2 does not equal 0, so we can ignore that. X plus 10 equal to 0, x minus 10 equal to 0. Subtract 10 from both sides. X equals negative 10. Add 10 to both sides. X equals positive 10. So our solutions are going to be negative 10 and positive 10. And that's our final answer. Alright, so if you have any questions, please raise your hand, call me over. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye!